dropping this video to describe the difference between displacement and total distance traveled using integrals. So if we remember, displacement is the solution of your integral. So all I'd have to do to find the displacement of this function on this interval is to take the integral from 0 to 3 of negative x squared plus 4x minus 3. So I'm just going to anti-derive negative x cubed over 3 plus 2x squared minus 3x evaluated from 0 to 3. I'm going to plug in 3, which is negative 27 thirds plus 2 times 3 squared minus 3 times 3. So that's negative 9 plus 18 minus 9, which is 0. So what this is telling me for my displacement is no matter how far forward and backwards I move, I'm going to end up even back where I started. So my displacement is 0. But I could have been moving the whole time. Way long amounts, but still just end up in the same position. So I want to know total distance traveled. I don't care if it's negative or positive, that is distance traveled. So what I need to know, is my function ever negative? Does it ever move backwards? Does it ever move forward? How does that all work? So I'm going to take this guy and I'm going to set it equal to 0 to see where my zeros are to find out where I'm moving forward or backwards, assuming this is my velocity formula. So I'm going to factor out that negative to make factoring a lot easier. So that is going to give me x minus 3 times x minus 1. So I have potential to see a change, forward and backward movement at 3 and 1. So I'm just going to take a check here, 1 and 3. If I plug in 0, that's negative, negative, negative. So that's negative. Between 1 and 3, I'm going to plug in 2. That's negative, positive times a negative. That is positive. And since my interval is 0 to 3, that's enough information for me right there. So I know I'm moving backwards from 0 to 1 and forwards from 1 to 3. So what I'm going to do is I'm actually going to split that into two integrals so I can turn this negative direction positive. And to do that, I'm going to go ahead and take the integral from 1 to 0. Remember, if I switch those bounds, it's going to change my integral from a positive to negative or negative to positive. Since I know I'm moving backwards, that area is going to be negative. So by switching my bounds, it should come out positive. So this is negative x squared plus 4x minus 3. And now I'm going to add that to the positive movement, which will be positive area, from 1 to 3. Negative x squared plus 4x minus 3. Yep, went off screen there, but there's a dx. You get it. I'll move back a wee bit here. All right, so now I just have to evaluate this. I'm going to have negative x cubed plus 2x squared minus 3x evaluated from 1 to 0. If I plug in 0, that is 0. And now I'm going to plug in 1. So I'm going to get negative 1/3 plus 2 minus 3, which is going to give me a negative 4/3. So that means I went backwards 4/3 unit. I know it's backwards because right there it is a negative, but because we switched those bounds, the negative became a positive. Okay? So then I'm going to do the same thing here. I have negative x cubed over 3 plus 2x squared minus 3x evaluated from 1 to 3. So if I plug in 3, that's going to be negative 9 plus 18 minus 9. And now I'm going to plug in 1, which is negative 1/3. I'm going to go off screen again, aren't I? Plus 2 minus 3. I did it! So this still gives me 0 minus, and again, I'm going to get that negative 4/3, which is positive, which tells me my total distance is 8/3. So that means I went backwards 4/3, then positive 4/3, ending up in the same position, which is why my displacement is 0, but my total distance traveled is 8/3. So when we're looking for that total distance traveled, we need to make sure that we're aware of when we're traveling in which direction, so we know how to split our integrals. Okay? Hopefully that makes sense. Hopefully that helps with some of the problems. If not, let me know.